which you factored into this. And then our goal is to decompose our original, our original shown here into this. Our goal is to get this to equal this, a, b, c. So right now we just have this huge function, and believe it or not, before we're done, despite how hideous this whole thing looks, we're going to have solved for a, b, and c. Now, let me ask you this. If we had this, and I'm totally making up this example, so don't try to solve it, but if we had something like what would I do? Exactly. You'll multiply by your common denominator, won't you? However, if you factor this correctly and set this up, this is your common denominator. Just like 16 would be the common denominator. Well, yeah, 2, 4, and 8. This is your common denominator. So the second step, every single time, will be to then multiply through by your common denominator, x minus 1, and x plus 1. We have to multiply our common denominator by every single piece. And you may think that's going to look hideous, but it's going to cancel out beautifully. When we multiply this by this whole part, what's going to happen? Everything's going to cancel, isn't it? The whole denominator, x minus 1, x minus 1, x plus 1, x plus 1. Poof. And all we're left with, and that's always going to happen if you do this correctly. That will always happen. So you're just left with the numerator. When you multiply these three by your common denominator, let's see, first the first one. What's going to cancel with the first one? The x, and you're left with a times x minus 1, x plus 1, plus b, the x minus 1's cancel, x plus 1, and c, which piece is going to cancel? X plus 1, leaving you with the x and the x minus 1. Now you could, as you do more and more of these, you're going to be able to skip some steps. You'll know to just pull down the numerator, and basically it's going to be like a cross multiplication kind of thing. Both of these are going to go with this one, both of these are going to go with that one, and both of these are going to go with that one. Now, here we go. What we're going to do now is we're going to plug in values of x that are going to filter out all but one letter. So, for instance, see how x, well, actually, what could I plug in for x just to this binomial that would make this whole product equal to 0 and therefore make a kind of go away? 1. If I plugged in positive 1, that would make a go away. And what else would that make go away? C, because this has an x minus 1 as well. So you're going to plug in 1 for x, and watch what happens. You plug in 1 for x, both sides. That becomes 4 minus 7, which is negative 3, minus 3, which is negative 6. I guess I'll write this off to the side. This is f of 1. Let's see, that becomes 0, poof. That becomes 1, and this becomes 2, right? So 1 times 2 times b. And this poof goes away as well. So b is negative 3. So I come back up here, and b is negative 3. And you're going to solve for each letter individually. What's a number I can plug in to make this part go away? What's that? Negative 1. F of negative 1. Let's see. That's going to be poof, poof. And what's this going to be? Negative 2, negative 1, so positive 2c. And then let's see, that'll be a positive 4 plus 7 minus 3. So 8, divide, and what is c? 4. C is 4. Before I go any further, questions about any step that I've taken? Everything. You get, well, this is the blue part. You get how we got started. Okay. And you get how we got to this line. By just multiplying through by the common denominator. Okay. Then, remember a function, you can plug in any x value you want. Just find out what the y value is. So if you notice, by doing this, every factor from up here occurs exactly twice. So if we plug in 1, for instance, that's going to make this A times 0 times 2. Well, what's anything times 0? So the A kind of vanishes on it, as did the C, which allowed us to solve for the B value. And then we did the same exact thing. We plugged in -1 for X, which made the A and B go away, and we were able to solve for C. Oh, we just plugged those same numbers into this side as well. All the way across. It's one huge function. All right. Other questions before I continue? Way up here? Yes, because we multiplied this by everything, that all ended up being. It's just like yesterday, how we had to multiply like sine t by every single piece. Same thing. Sometimes it just cancels. What would we plug in to find for A? Find A. Anybody? 0. Because there's just an X with these pieces, but not here. So if we plug in 0, that's going to be 0C, 0B, and then -1 and +1, negative A. So that would give us f of 0. Let's see, 0, 0, -3 would be -3 equals negative A. So what would A be? And you're done. You have decomposed your original, which is actually back over here on the DOM, into this, and that's our goal. And you're done. This right here is your finished answer. This is your decomposed original problem. To my knowledge, and I'll look through the answer key to make sure of this, we're not going to have any today to get into ugly decimals and fractions. I mean, not that that would be a problem. Even if we got -2/7, just write it up here. -2/7 in parentheses. You don't have to simplify that. You can just leave it. Questions on that problem? We're going to do more. Sure. Good question. You could check your answer if you want to work backwards and put it like that, then you would have to. I know what I want to say, but I'm thinking how I want to say it. Okay. If we had 1/7 plus 2/14 plus 3/18, how could I combine those? Common denominator. So I'd have to multiply this top and bottom by both of those. I'd have to multiply this top and bottom by both of these, and this top and bottom by both of those. See, by doing it on the top and bottom, you're really just multiplying it by 1, so that's why it's bigger. Checking these is going to be a pain in the head. I really wouldn't. I have an answer, but you can check them too. But like as far as tests, easiest way to do it, in my opinion, easiest way to check your answer, like on a test, would be, this is really what you need for them to equal, right? Easiest way, take both of those, multiply it by the 3. Take both of these, multiply it by the 4. Both of those, multiply by this. Add all that together, and it should equal the top. Yes.
Like on this one, our denominator at first reduced to x minus 1, x plus 1.
Okay.
Now, on this one, we put the x minus 1 under the b. Does it matter if you put it under the b or the c? It would still work out the same?
That's correct.
Okay.
Let's say, that's a good question. Let's say we had these three all mixed up. Let's say you have the x here, x plus 1, x minus 1. Here's the thing. Now, if you turn to somebody next to you and say, what did you get for A? They're going to tell you something different because their A is over something else. But when you rewrite your answer, their 3 over x would just be down here. Your 4 over x minus 1 or plus 1 would be over here. It'd be in different order, but the same number should be over the same binomial. Okay? Okay, let's look at another one. I believe we just did number 19 just now. Let's see. Now, again, the degree will tell you pretty much how many you're going to have. The degree will tell you how many you're going to have. 27. Well, okay, no problem. The only problem with 27, I was going to do one more straightforward one. Here's the problem with 27. How many am I going to have? 3. That's right. But you only have 2 actual factors of that, don't you? What's that? Yes, but you can't have the same thing. That's actually not that huge of an issue, but there is something I have to show you about that, which I'll show you in a second. What I first want to worry about are the ones that we can factor down to individual terms. Okay, 13. In fact, I might just saw this lesson in half and we'll do those tomorrow. We might. I don't know. 13. Because this is just a throw-on lesson. It's not meant to take all day. I think I will solve this in half. Okay. First step is to what? Back. Very good. And who can raise their hand and tell me what that would be? Justin, what would that be? Yeah, x minus 4, x plus 3 I think would work. Okay, very good. Now, since we have these in nice individual terms, we can just stick a letter over each part. Now, this one's only going to have how many? 2. This one won't be so bad. A over x minus 4 plus b over x plus 3. Marco, what was the next step? Do you remember? Okay. It might rhyme with multiply by your Mammon condominator. There you go. All right, now. Yes. No, that 7 is married to the X. It would be really mad if you tore her husband away from her. I don't know why it's a her, but it is. Okay. Now, you're going to multiply by the common denominator of x minus 4, x plus 3. And you're more than welcome to go term by term. But here's pretty much how it's always going to work out. You're always just going to have your numerator on the left. And then a is going to have every piece not with the a, so x plus 3. And the b is going to have the piece not with b. That's how it's always going to work out. Even if there were 40 terms, there won't be. But even if there were, everything that's not under the A is going to get tacked onto the A. Everything not under the B is going to get tacked onto the B. That's just the nature of how these things are going to break down. Okay. So, what can I plug in to start getting rid of stuff? Ashton, what do you think? What can I plug in? Negative 3 would help us solve for what? B. It'll get rid of the A and help us solve for the B. So f of negative 3, what would that be? Negative 21 minus 4? And then negative 3 here. Oh, really? Negative 7b? I don't think you'll have too many ugly ones like this, but I'll look in the book in a second. So what's B going to be? Over 7. Did I do that right? Ugh. Can't believe we ran into an ugly one this early. No big deal. Now, the proper way to write this, if you write this, I won't care. That's fine. The proper way to write this would be like this. 25, and then stick the 7 on the bottom with the x plus 3. I don't care how you write it. If you look in the answer book, it's going to look like this, or in the back of the book. But if you leave it on the top, I don't care. So anyway, what are we going to plug in to solve for the A? Positive 4 sounds good. So that'll give me, what, 28 minus 4, 24, equals 7a, another one? Okay. So what's a going to be? 24 over 7, which I'll just leave like this to indicate I don't care which way you write it. This is more accurate, but this isn't algebra class. This is pre-calculus. So And that one's done. You're finished. If you want to find it as a decimal, I guess that's fine. The fractions are more accurate. So here you go. That's it. Sure. Well, is that a correct factorization of our original? I don't think so. No. Questions? Yes. No. This is really all I need to see. Other questions? What? I think I heard a mumble. Does somebody want to see one more? Okay, one more. Yes. Thank you. I forget to do that. I'm glad you reminded me. Oh, I'm glad you like it. Okay, let's see. Try 17 down there. 17. Yeah. All the other ones on the page are either only 2 or they're pre-factored, unfortunately. We did the hardest one in the DOM. So I'm just going to put this one real big on the board. This one's nice and factored for you, so all you have to do is decompose it. Try that. While you're working, raise your hand if these apply to you. If you're going to be taking the English 3 and of course on Thursday, raise your hand. Oh, that's not too bad. That's good. Sorry guys, means probably going to move on. It must have hit a shot. If you're taking the AP English exam on Thursday, raise your hand. Okay. AP Biology, who's taking that one? All right, we have minimal interference in this class. Yeah, isn't that good news? No free days. Yeah, I get out of it. I'm going to work it up here. If you want to check your work, that would be ideal. Again, you may have done it in a different order than me, but I doubt it. This one's pre-factored. You know? Yeah, that's it. Didn't you already take this? Oh, I didn't check that. That's true. You want to take that one tomorrow? Yeah. All right. You can check your stuff on the board, see if yours matches mine. I tried to color code so it'd be obvious to be where I plugged in stuff. Somebody got something different than me. Anybody else want to take a look at their paper? Yes. And that's tomorrow when we get into stuff where we need to pay the data. Then going down the negative. All right, well, I'm going to go ahead and cut the roots then. Sure. And I'm going to change the assignment, so don't write it down immediately. I forgot when I loaded this that I sawed it in half last year too. So, all right. Here's your assignment, but I'm changing the numbers. Sorry about the repeated review problems yesterday. That shouldn't have happened today.